Excuse me, hello, Mr. Gazda here, Intro to Vectors, the cart method. So hopefully we have done the demonstration with the cart in class. This shows the cart like from overhead view, and we're going to be different sort of pushing or forces on the cart and see what the resultant force is. This is definitely problematic for students. That's why I get to the cart idea, but normally the cart's not part of this. So this is just my way I help people understand it. So key thing, resultant force is the net or overall force that exists when multiple forces are added together, and that's what we'll be doing today with the head-to-tail method. So follow these directions. You're going to use a pencil, and we're going to always, the key thing is the resultant vector. Darken it, label it R, and direction is key. You must, direction of this is super important, and it's the one that students often mess up. So here we go. Let's do the first one here. So if this is the cart and someone's pushing it this way, and the length means how strong they're pushing it. So this is a pretty strong force. This is a strong force this way. This is less so in this direction. Let's add them together, head to tail. I could pick any one of these to choose with. I could pick any one of these to start with. I'll pick this one. I will add that one to it. So I go like this. I want to get the length right for sure, because the length represents how strong that force is, or we call it the magnitude of the force. So then you go like this. This is our head to tail method. You go like this. I'm doing it in red pen so you can see it, but you should use a pencil. So that's that one. I transferred it over. Now I have to do this one, and I'm going to do it like this. I'm going to mark it here. I'm going to mark it here, and I'm kind of eyeing up the direction a bit. Usually that's kind of bad to be doing it like that, but we're trying to make this a little bit easier. Okay, so then that's where I end up after all three forces are added. So I think I have in there, I have draw in the location of the cart. So the location of the cart kind of would end up here, basically. This is the cart. And then you want to draw in the resultant force of all these three added up. That's what's key. You start here and you end here. Okay, these are all head to tail, but the heads go there. And that is the tricky part. So I'm going to do it like this, carefully with a rule. I'm going to go like this. I'm going to draw it like this. And the key thing is the force goes that way. I'm going to draw a big head on it like that, and then that is my resultant force. I'll even go over it in green maybe so you can see it better. Okay, and the arrow going this way, that is key. It has to be really clear what direction it's going, because obviously the direction of forces are very important. Okay, that's the first one. Number two, same situation. I have these three. I'm going to add them together. I'm going to start with, I'll start with this one. And I will, actually, I'll start with this one. I'll add this to that one. Any order you go in, it doesn't matter. You have to, as long as you include them all, they'll all get you to the same spot, okay? All get the same answer, basically, is what I'm trying to say. So I go like this, and I will mark this so you can see it there. That's the length, and I'm going to add it to this like that there. So in this case, it's going to be here, there to there, and then that's the head or the direction of it, and I'm going to add that to it. So I'm going to mark that like this and mark it like that, and go like this, mark it to there. Okay, and then that is going to head to tail. That's kind of the add. So now I'm here. I would draw in the position of the cart. So that's the center of the cart. I think that the cart, it can really help people visualize it, but the resultant force of those three added together is here to here, and it's going to look like this. Right there to there, I'm going to go like this, okay? Draw a big arrow or head on it showing the direction of the force. Okay, label it R. Okay, label it R. And again, I'm going to color it over in color. And label it R. Okay? I think that this is a pretty straightforward concept, though I've learned that students really have trouble with it every year. So if you do, don't sweat it too much. Let's do the next one. Okay, I'm going to do this. I will start with this one. I will add that to it, just because that's what I decided. So again, marking it like this, there to there, there to there, and then I'm going to go like this, here to there, and I'm getting the directions right. I'm trying to eye up the directions there. Again, most physics classes, physics teachers, they would like lose their mind if they saw this eyeing it up, but I'm trying to get the point across here. So, and then I'll add, maybe I will add this to it. Okay, just, again, the order doesn't matter. There to there, and then I go like that, going to try to really get this sort of straight up and down direction of it. I made the directions of it as clear as I could, there to there. So, and then I have one more left, that one. So let's get that there. Go like that, there, and then we're going to do this. And that's going to get you to there, there. Okay, so that's kind of the ending point. So our resultant force is from the beginning, well, I'll draw on the cart. Cart would be there. And then we go like this. That is the resultant force, the net force of all of those, whatever, 4 forces right there. Highlighting it in green to show that it's the resultant force and not the other 4 forces. Okay, so that's what the resultant force would be. 4 now has only 2 forces on it, so here we go here. I'm going to take another piece of scrap paper. You need a lot of scrap paper here, so I will, maybe I'll add this to that, so. Again, order doesn't matter. As long as you do them all, you'll end up in the same resultant force in the same spot. And the cart will be in the same spot, same resultant force. Do that. The cart will be here. Okay. And then the resultant force overall of these 2 forces on the cart. Here. This direction, get the arrow right. Label it R for resultant. That has to happen too. Okay. 5, here we go for 5. Add these. I'm going to add, I'll start with this one. I will then add this one to it. Sometimes I add them up to make sure I'm not, if you go over the lines again, sometimes it's a little challenging. But that's fine. It still will work. It just makes it a little more. I'm doing that and it's going that way, so like that. Then I'll add this to it, which is from there to there. So I go like that, and I want it to sort of straight up and down on the paper. And then from there to there to there. Scrap paper does not end up being a good straight edge. And then so I have this one. I got to add this one. So now I'm kind of going back in that direction. There, which you see, like this kind of cancels out some of that direction. This is actually a little bit longer, so they actually are opposing forces. This is a little bit stronger, so they will, if you can visualize it, we'll just cancel it out a bit. And you can see how this brings you that way. This is bringing you back the other way. You may or may not be able to see that, but that is true. Okay, so now you end up there. I'm going to draw in the cart. Here we go. There's the cart, and the resultant force is going to be like this. Okay, there to there. Okay, label that R, and again, I'm big on the green today. We'll go over with the green. There, and there. There you go. So that's that one. Okay, what am I got? I'm about 8 minutes in here. So what I did, just to shave up some time here. Thank you for your patience. This is what I got. So I started with this one. I added this to it. Then I added this, and then I added this. Ends up there. This is my resultant force here. Okay, again, direction's key. You can probably see 8. I'll go back to 7 in a second. 8 is just these 2. Now, I add the following vectors without the cart as a visual aid. So, in general, the way we normally do vectors, the cart, we don't do the cart, so you just add them together. So, in this case, I actually started with this one. I added this to it, so it's only 2. This is my resultant force right here. And this is a pretty sort of straightforward example. It's just those 2. Okay, I'm going to go back to this one, because this is interesting. I reverted purposefully. This line here is just an annoying thing from the photocopier. Disregard it. So, which one should we start with? Which one should we start with? All right, good choice. Let's start with this one. I like it. And then we'll add this to it. Okay, so what I'll do. Just go like this and go like this. And then I'm going to try to get the direction right as best I can. The direction is key for this one in particular because I know how it goes. So it's that one. Now I'll add this one to it. I can add this. I'm going to add this one to it, which is going to be like this, like that, like that. Okay. Gets me to there, which is unique that it goes to that spot, but And then I got to add this to it. That is like this. From there to there. So look at that. I drew this so now I'm right there. So think about, where's the final resting space of the cart? Well, it's like right there. It's in the same spot. It's in the same spot. What's the resultant force? None. No resultant force. Now, in regular words, the best way I would describe this is if 4 people are pushing on the cart, but their forces are all sort of counteracting each other, and the cart doesn't go anywhere. So this person is pushing this way, this person is pushing that way, the same strength, so they cancel each other out. And then this person is pushing that way, this person here is pushing the opposite way, they cancel each other out, cart doesn't move, cart is stationary. No resultant force. Okay, so that's, hopefully you get that, because I think that's cool. And then on the back I got this. So what I did here, again, just to save some time, so I started with this one, I added this to it, added this to it, the resultant force from here to here, okay, like this, label it R, key to have the arrow be very clear what direction it is. This one is a little hard, so I think I started with this one, I added this to it, okay, then I added this to it here, and so this is my resultant force. It kind of overlaps that line, which happens sometimes. Okay. Okay, and so that's the resultant force there. And on number 11, what I have here is, so I started with this one. What did I add to it? I added, it could have actually did it in a different color. I added this to it. Then I added this one here. And then this one here. Brings me to there. The resultant force of these 1, 2, 3, 4 forces is this in this direction. Okay. So I think this is a pretty good introduction to these type of forces. So hope you enjoy it. I'm Mr. Gazda, and I approve of this vector homeworky thing.